This is Algebra 1B, Part 1, Unit 2, Lesson 8, Exponential Growth and Decay. Okay. Whether something grows or decays, gets larger or shrinks by exponential growth or by exponential model, is determined by what you multiply by. If you multiply by a number greater than 1, the number will get bigger. If you multiply by a fraction less than 1, the number will get smaller. Let's look at two towns. Let's look at Boomtown. Boomtown is said to have a population of 10,000 people. Okay, and it is growing 4% per year. Okay, so what we're saying is this: if last year the population was 100%, the next year it'll be 100% plus 4%, or 104%. Okay, expressing that as a decimal by moving the decimal 2 hops to the left, that's the same as 1.04. Okay, so this is the base of the exponential function. This is what we multiply by. Notice it's a number greater than 1. It's 1 and a little bit more, so it's going to represent growth. Every year is going to be 100%, the whole, plus another 4% every year. And so we can use the formula y equals a times b to the x, where a is the start value, b is the base, in this case 1.04. Y represents the population, and x represents the years. Okay, so in this particular case, y equals a, the start value, 10,000 people, plus the base, or times the base, 1.04 to the power of x. Okay, let's go ahead and graph that here in Desmos. So Desmos, okay, we're going to graph y equals 10,000 times 1.04 to the power of, that's shift 6, x. Now we're not going to see anything on the graph because we're way too close. These numbers are large. So I'm going to change my scale here. I'm going to change my x-axis to go from 0 to, let's say, 50 years. Okay. I'm going to change my y-axis, which is people, to go from 0 to 100,000. There we go. Okay, 0 to 100,000. And here is our graph. You can see the characteristic ski slope, taking off like an airplane off of a runway, going off and up to the right, going down to 0 on the left side. That's the classic exponential growth model. Okay, so that's Boomtown. Boomtown is a town in growth, right? Okay, Shrinktown. Shrinktown has a population of 100,000 people, so it's pretty large. But it's experiencing decay of 4% per year. That means that the population goes down 4% every year. So the multiplier we're going to use is this model. 100% was last year, but next year it's going to be 4% less. 100% take away 4%. 100 take away 4 is 96%. Express that as a decimal by moving the decimal 2 hops, 0.96. And that becomes the base of our exponential model. So using the same formula we used before, y equals the start value, 100,000, times the multiplier, 0.96, to the power of x. And now let's graph. Let's take a look at that function on the same set of axes. So y equals 100,000 100,000 times 0.96, let's keep the same notation, times 0.96 to the power of x. You'll notice now this represents decay. We are actually experiencing a decline over time. We can even find out when the two towns will have the same population. In about 28 2/3 of a year, in the latter half of the 28th year, the population of both towns will be 30,903 people. Okay? And so we can answer all kinds of questions about it. So notice the start value. It started at 100,000, declines 4% every year. 4%. Every year it's 4% of what it was the year before. The boomtown started at 10,000, and it goes up 4% every year. Okay? So that's the difference between exponential growth and exponential decay.